Volcanoes are mountains, but not just any mountains. They are mountains with a fiery secret. Deep inside, they hold molten rock called magma. This magma is under immense pressure. Sometimes this pressure builds up and the volcano erupts. Volcanoes are a powerful reminder of the forces that shape our planet. They show us that Earth is alive and constantly changing. While they can be destructive, they also create new land and enrich the soil. The study of volcanoes is important. It helps us understand the Earth's history. It also helps us prepare for eruptions and keep people safe. Volcanoes are both beautiful and dangerous. They remind us to respect the power of nature. Let's learn more about these amazing geological wonders. Before a volcano erupts, it usually gives off warning signs. These signs tell scientists that something big is about to happen. By monitoring these signs, we can predict eruptions and keep people safe. One of the most important signs is seismic activity. As magma rises in a volcano, it causes the ground to shake. Scientists use instruments called seismometers to measure these earthquakes. Another sign is gas emissions. Magma contains dissolved gases like sulfur dioxide and carbon dioxide. As the magma rises, these gases are released into the atmosphere. Scientists measure these gas emissions to track the movement of magma. Ground deformation is another important clue. As magma pushes upward, it can cause the ground to swell or bulge. Scientists use GPS and other instruments to detect these changes in the volcano's shape. By carefully monitoring these and other signs, scientists can often predict when an eruption is likely to occur. This gives people time to evacuate and prepare for the eruption. Not all volcanic eruptions are the same. Some are explosive, sending ash and rocks high into the air. Others are effusive, with lava slowly flowing down the sides of the volcano. Explosive eruptions are the most dangerous type. They are caused by the rapid expansion of gas bubbles in the magma. These expanding gases create enormous pressure, which can shatter the surrounding rock and send ash and gas high into the atmosphere. Effusive eruptions, on the other hand, are less violent. They occur when the magma is less viscous, meaning it flows more easily. In these eruptions, lava flows out of the volcano and down its slopes. The type of eruption depends on several factors, including the composition of the magma and the amount of gas it contains. Understanding these factors helps scientists predict how a volcano is likely to behave. Volcanic eruptions can have a dramatic impact on the surrounding environment. The effects can be felt for miles around the volcano, transforming the landscape in a matter of hours or days. One of the most visible impacts is lava flow. Lava can flow for miles, destroying everything in its path. As the lava cools and solidifies, it creates new landforms, such as lava fields and lava domes. Another significant impact is the release of ash and gases. Ash can blanket the landscape, suffocating plants and animals. Gases like sulfur dioxide can react with water vapor in the atmosphere to form acid rain, which can damage crops and pollute water sources. Pyroclastic flows are another deadly hazard. These are fast-moving currents of hot gas and volcanic debris that can race down the slopes of a volcano at hundreds of miles per hour, incinerating everything in their path. Section 5. Impact on human life. A tale of displacement and resilience. Volcanic eruptions can have devastating consequences for human life. Throughout history, eruptions have caused widespread destruction, displacing communities and claiming countless lives. The immediate dangers include pyroclastic flows, lava flows, and falling ash. These hazards can bury cities, destroy homes, and disrupt transportation and communication networks. Volcanic ash can also pose serious health risks. The fine particles can irritate the lungs and eyes, causing respiratory problems and other health issues. Ashfall can also contaminate water supplies and damage crops, leading to food shortages. Despite these risks, humans have shown remarkable resilience in the face of volcanic disasters. Communities often come together to support each other, rebuild their lives, and adapt to the altered landscape. Section 6. The long view, shaping the Earth over millennia. While the immediate impacts of volcanic eruptions can be devastating, over long periods, volcanoes play a vital role in shaping the Earth's surface and influencing its climate. Volcanic eruptions release gases and particles into the atmosphere. These emissions can have both cooling and warming effects on the climate. For example, sulfur dioxide can reflect sunlight back into space, leading to a temporary cooling effect. On the other hand, volcanic eruptions also release carbon dioxide, a greenhouse gas that can contribute to long-term warming. Over geologic time, volcanic activity has played a significant role in regulating Earth's climate. Volcanoes also play a crucial role in the rock cycle. Eruptions bring magma to the surface where it cools and solidifies to form new igneous rocks. These rocks are then weathered and eroded, contributing to the formation of sedimentary rocks. Section 7. Famous eruptions throughout history, stories of destruction and rebirth. History is replete with tales of volcanic eruptions that have left an indelible mark on human civilization. These events serve as stark reminders of the immense power of nature and the importance of understanding and respecting its forces. One such event was the eruption of Mount Vesuvius in 79 AD. The eruption buried the Roman cities of Pompeii and Herculaneum under a thick layer of ash and pumice, preserving a snapshot of Roman life frozen in time. Another catastrophic eruption was that of Krakatoa in 1883. The Indonesian volcano erupted with such force that the sound was heard thousands of miles away. The eruption triggered tsunamis that devastated coastal communities and released so much ash into the atmosphere that it caused global temperatures to drop. More recently, the eruption of Mount St. Helens in 1980 demonstrated the destructive power of volcanic eruptions in the modern era. The eruption, the deadliest and most economically destructive volcanic event in US history, reshaped our understanding of volcanic hazards and highlighted the importance of monitoring and preparedness. Section 8. Monitoring and mitigation, listening to the Earth's heartbeat. Scientists today have a wide array of tools and techniques at their disposal to monitor volcanoes and predict eruptions. By studying the behavior of volcanoes, we can better understand the risks they pose and take steps to mitigate their impact. Seismometers, GPS receivers, gas sensors, and remote sensing technologies allow scientists to track the movement of magma beneath the surface, detect changes in gas emissions, and monitor ground deformation. This data provides valuable insights into the inner workings of volcanoes and helps scientists forecast eruptions. While we cannot prevent volcanic eruptions, we can take steps to reduce their impact. This includes developing evacuation plans, creating hazard maps, and educating the public about volcanic hazards. Section 9. Conclusion: living in harmony with nature's fury. Volcanoes are a powerful reminder of the dynamic forces that shape our planet. They are capable of both immense destruction and creation, leaving an indelible mark on the Earth's surface and the course of human history. While we may never be able to fully control the awesome power of volcanoes, through scientific understanding, careful monitoring, and effective preparedness, we can learn to live in harmony with these awe-inspiring geological wonders. By studying volcanoes, we gain a deeper appreciation for the Earth's dynamism and our place within its grand scheme. As we continue to unravel the mysteries of these fiery giants, we equip ourselves with the knowledge we need to mitigate risks and ensure the safety and well-being of communities living in the shadow of volcanoes.